Hey there, I'm Mr. Rose, and today we're going to talk about write-in question again from the textbook, University Physics. That is the 13th edition, Young and Freeman. It is the book that we use the most when we talk about these things. And these write-in questions just happen to be right in the book. These discussion questions, really good. Right now, we're going to look at a question that comes from one of our audience members. We'll call that audience member 25.5. That's question 25.5. You can read it right now. You can see, I'll even highlight it. I'll get weirdly close. Ooh, that's kind of creepy. That is what we're looking at, question 25.5. So take a look, read that over while we set up right behind me. All right, so question 25.5 asks us a really interesting question. Let me ask you the same question. When is a 1.5 volt battery, that's what I have right here, when is a 1.5 volt battery not 1.5 volts? So this is going to really be part of our introduction to really upper level physics, really real life stuff. Now, this 1.5 volt battery, if I put a voltmeter across it, may be a little more than 1.5 volts, maybe a little less than 1.5 volts, and I'll explain that at the very end. But if we go back to what you may have learned in a very introductory class, I'm going to draw a simple circuit right here where I have a battery, and I'm going to put a light bulb in it just because I want to put the light bulb in it, and 1.5 volts. And we've always drawn circuits in that kind of fashion, where I have the plus side and the minus side. Hopefully we can see that. And that would be 1.5 volts, and everybody's happy. Now, in our class, we don't do that so much. In a real life or more realistic thing, we know that we've always talked about wires as perfect wires and batteries as perfect batteries. We never even had to explain that. But we're learning things about resistivity and conductivity. And a battery has a resistance. We call it an internal resistance. So if I were to draw a real battery, I'm going to get rid of that. Well, I'm going to keep that there. And I'm still going to put my small and my big, my plus side, my minus side. But I'm going to attach to it, I'll just put it in a different color so we can see it. That is not the thickest marker. Try that again. That is the same black. So much for that. And I'm going to put a box around that. Oh, we'll see that one. Now that is going to represent my battery. Let me draw the rest of the circuit now. And everything else is the same. So what's going on here? This battery has a little resistor in it. And now, even if this battery was labeled 1.5 volts, maybe it's not actually 1.5 volts. So how do I figure that out? Well, we know Ohm's law. And Ohm's law also is going to be applied to our battery. Well, we know V equals I times R, but what is that? The very first time we ever heard voltage potential difference, simple circuits, we may have heard the word EMF, or an electromotive force. That EMF is brought to us by a little script E, something like that. Now, mine is not very neat because I'm me, and you all have learned that by now. But if I were to draw this, if I wanted the voltage or the potential difference of my battery, then that would have to account for this internal resistance. Well, I know that I have electricity or charge carriers coming out of the positive side, high potential to a low potential. So my battery, that is going to be this EMF that I just defined minus I times R, where I is the current and R is the resistance of the battery. Now, this is our internal resistance. Sorry, that is very sloppy. That is my internal resistance. Now, this V battery, if I wanted a 1.5 volt battery, so if I wanted this to be 1.5 volts, there's a chemical reaction in here that caused me to have some kind of potential difference, such that my battery provides that electromotive force. Now, the EMF of the battery, this may actually be this guy, might be 1.5 volts. but my actual measurable, if I took a voltmeter and measured there to there, I may only get 1.2 volts. Now, if we really wanted a 1.5 volt battery in real life, what that means, if I wanted V battery to be 1.5, my EMF would have to be slightly higher than that, such that I can measure 1.5 volts after accounting for that internal resistance. This is something that we're going to get into that's actually explored even more in the next chapter when we start talking about Kirchhoff's loop laws. We have to account for that resistance of the battery. But there's your answer. I know it's been burning you up. When is a 1.5 volt battery not 1.5 volts? Well, the answer is simply always. That's all I have for you on this edition of Ask Your Physics Teacher. Please, by all means, keep writing in those questions. And when we have more money, we'll get a new edition of a textbook. We'll have a whole set of new written-in questions. As always, if you'd like, follow me on YouTube. Please feel free to like, comment, or subscribe. And keep your questions coming. You'll see me next time.